Hey folks, in this video we're talking about Lewis dot structures. So order much structure. So yeah, I want y'all to be able to draw Lewis dot structures for elements, which is pretty easy peasy actually. And what I really want you to be able to do is draw Lewis dot structures for compounds, which is not as easy peasy, but it's actually not too spicy. We'll learn how to do it. Let's do it. The Lewis dot symbols for elements. What they're gonna do is show the element symbol. So like oxygen, they'd show a little O. Or if it was our friend phosphorus, we'd show a little P. Oh, I gotta do it backwards. A little P. So they're also going to show how many valence electrons the element has. So oxygen has 6 valence electrons, and we're going to use the electron configuration of the element or the group numbers to help us determine how many valence electrons the element has. And we're mostly going to do these for main group elements. We're not going to really mess around with our D block or transition metal friends, definitely not our F block homies with this stuff. And so usually we represent our electrons with dots. Neat. So the electrons are going to be positioned around that symbol. The way we're going to do that is going to place them on 4 sides, like top, bottom, and 2 other sides, left and right. And so we're going to put our electrons down one at a time or singly first. And then once we have one on all 4 of our sides, we'll start to double them up and put them in pairs. So let's look at some examples. We got fluorine, our symbol's F. 7 valence electrons. So I'll plunk down an F and I'll put down 1 electron on each of the 4 sides. That's 4. And now I've got 3 left to make 7. So I'll start doubling up and make little cute electron pairs. Oh, little pairs. Neat. So we could also do carbon. Carbon's symbol is C. I've got 4 valence electrons. So I'll drop down a carbon and I'll put down my 4 valence electrons and I'm done. I don't have any more to put down. So that's how we draw Lewis dot symbols. Not too spicy. But Lewis dot structures, let's talk a little background before we talk about how to make them. We're going to show how elements are connected in a covalent compound. You might see them in other types of compounds, but not as often. And so the bonds between elements are usually represented with a solid line. You might see different things in different structures, but for our basic Lewis dot structures, we're just going to use a solid line. And so if we wanted to show multiple bonds, like a double bond or a triple bond, we would use 2 lines for a double bond, or we would use 3 lines for a triple bond. So these are going to show how electrons form bonds or lone pairs on different elements in a compound. So the electrons are either going to hang out in bonds or usually like to pair up in orbitals. So each bond or lone pair is going to consist of 2 electrons. That's nice. Everything in 2s. And so a double bond is the equivalent of 2 bonds, so that would be 4 electrons to make a double bond. All right? So structures are going to be based on how many valence electrons are in the compound, and we'll talk more about that in the next slide. Let's look at some examples. Oh my gosh, it's some water. Here it is. Check it out. It's a Lewis dot structure. Or here's some CF4, some carbon tetrafluoride. I said that wrong. Neat. And here's another structure, some hydrocyanide. And so here we've got a lone pair, our 2 little dots shown by themselves, and we've also got a single bond represented by that single line. And over here is a triple bond. You can see we've got those 3 lines together that represent the triple bond, which makes up 6 electrons. Neat. So let's learn how to draw these dudes. And we're going to start with my homie NF3, mononitrogen trifluoride. So first thing we got to do is determine the total number of valence electrons in the structure. So we're going to look at each one of the elements that's in the structure, and we're going to say how many valence electrons they have. We'll add them all up, and ta-da, we'll do it. Oh, dear, I seem to have made a mistake. These should all be Fs. Let's change that. Okay, so we've got 26 electrons total. Each of our fluorines gives us 7, and the nitrogen gives us 5, so 26 total. Neat, we know how many electrons we have to play with. So next, we're going to place the element with the lowest electronegativity as the central atom, except for hydrogen. Hydrogen's pretty much never going to go in the middle. And so in this group, nitrogen has the lowest electronegativity. You can also usually say the one with the fewest valence electrons will go in the middle, except hydrogen. So I can put that down in my structure. I'm going to draw my structure over here. And so now I want to connect all the other atoms to the central one with 1 bond each, because everybody's got to get connected. I'll put in my fluorines, and I'll hook them all up, that nitrogen, 1 bond each. So I got to keep track of my electrons that I use because I need to make sure that I place 26 valence electrons in this structure, no more and no less. So each bond is 2 electrons, 3 bonds is going to be 6 electrons, so 6 out of my 26 have been placed so far. Neat. Everything's connected. Now what we're going to do is add electron pairs those outer elements to fill up their octets. So I'm going to put lone pairs on all of my fluorine. Each of these fluorine wants 8 electrons. 2 electrons are coming from these bonds. So we're going to need to give them 6 electrons from lone pairs. So I'll start popping those in as some cute little pairs. Oh, they're so cute. And once those are all in, we've got, that's going to take up 18 electrons, 18 plus 6. Well, that's going to be 24 electrons have been placed. Well, we still have 2 left. Last thing we're going to do is add our remaining electrons to that central atom. So I'll just pop a lone pair, last 2 onto my nitrogen. Done. Nifty. And that would have used up, I was at 24. I've used 2 more, so I've used up 26 of my 26 electrons. So this structure looks good. Good to go. So that's the basic process. Things can get a little bit weird though. As I said with hydrogen, it's never going to go in the middle. What you also know about hydrogen is it only needs 2 electrons to have a full shell. So that means hydrogen is only ever going to form 1 bond. It's never going to get lone pairs on it. Hydrogen's like, bam, give me a bond, I'm good to go. Boron is another thing you should know about. Boron's a weirdo because it doesn't need to fill up its octet. It's pretty happy with only 6 valence electrons. So you can find boron with just 3 bonds and it'll be like, that's cool, I'm good. Other weird stuff is sometimes we have expanded octets or we go beyond the octet. So some elements that are in the 3rd period row of the periodic table or below, they can have more than 8 electrons in their structure. And so what these elements are doing is they're actually using their d subshells to store electrons and assist in bonding. It's pretty rad. I'm not gonna lie, it's pretty dope. Yes, very cool. So the other thing is multiple bonds. When we use multiple bonds, that's going to be if not all of the elements have an octet after we've placed all of the Lewis dot structures, or all of our electrons in the Lewis dot structure. Usually this will happen when you filled up your outer elements, but the central element still needs or is lacking an octet. So what we'll do in this case is we push an electron pair from one of our outer elements. If this is our middle guy and this is our outer guy, we take one of its electron pairs and we put it in the middle and we make it into a bond. And we'll see that in the next slide. Let's do that. Let's practice drawing some structures. So CO2, this one's a little spicy. We're going to go through this and we'll say, all right, it's carbon. It's 2 oxygens. So carbon's going to give us 4. Each oxygen is going to give us 6. 4 plus 6 plus 6 gives us 16 electrons. Carbon's the least electronegative. We'll plunk that down for the middle of my structure. What I need to do next, I need to attach those oxygens. We'll attach them with a 1 bond each. Nifty. And so that's 2 bonds, gives me 4 electrons. I've got 12 electrons left now. I'll put some lone pairs on my oxygens now. That's my next move. Populate the outermost elements with electrons. So I can put 6 electrons in the form of 3 lone pairs onto each of these. So that's going to be 6 lone pairs, 12 electrons, because each lone pair is 2. And that uses up all my electrons. So carbon's not happy right now. Carbon only has 2 bonds on it. 2 bonds is like 4 electrons. Carbon's like, all right, I got 4. I need 4 more to have an octet. What we're going to do is move lone pairs off of those oxygens to make bonds. So we can imagine these 2 electrons are like, you know what, not a lone pair. I'm going to be cooperative and help with bonding. And we can redraw that by, instead of removing them, turning them into a bond. So now carbon's like, all right, I got 1, 2, 3 bonds. That's 6 electrons. Well, we can move another lone pair. Let's take it off of the other oxygen. And so now we get rid of the lone pair that was there, and we turn it into a bond. And now carbon has 1, 2, 3, 4 bonds. Each bond is 2 electrons. So that's, can I do it right? No, I didn't do it right. That's 8 electrons. Oxygen has an octet. Lit. Why don't you check out this next one? See if you can go through and do this yourself. Try drawing a structure for boron. Remember, boron and hydrogen are weirdos. Maybe pause the video and go back to the previous slide if you need a refresher on the weirdos. Cool. Well, you paused the video and you tried that out. Let's do it together. So boron, hydrogen, hydrogen, hydrogen. Boron's got 3 valence electrons. Each hydrogen has 1 valence electron. Gives us 6 total. Boron's the least electronegative. Maybe it's less electronegative than hydrogen. I'd actually have to look at a table right now. I'm not going to do that. But hydrogen never goes in the middle. So boron's going to go into the middle of our structure. And we need to attach each one of our hydrogens with 1 bond, as I am. Well, that's going to be 3 bonds and 6 electrons. And dude, that's all of our electrons. We have no electrons left. And that's cool, because hydrogen only wants to have 1 bond. They're all good. And the boron only needs to have 6 valence electrons. 6? That's 3. 6 valence electrons. And so each of our 3 bonds is going to give us 2. So 2 plus 2 plus 2 gives us 6 valence electrons. Boron's pretty happy. Sweet. So we've got 2 cool Lewis dot structures right there. Sick. So I hope you feel pretty cool about Lewis dot structures and also the symbols, which are super easy peasy. And I hope you have a great rest of your life. Ta-ta.